Hello and welcome. In video 16 and video 18, we explained the ReLU and Leaky ReLU activation functions. In this video, we will explore another variant known as Parametric ReLU, abbreviated as PReLU. Before proceedings, let's have some assumptions. The input x equals 2, the weight w equals minus 0.5, and the bias is 0 for simplicity. The weighted input is computed as usual and serves as the input to the activation function. Before diving into PReLU, we will briefly revisit ReLU and Leaky ReLU. So, let's start with ReLU. Look at this simple neural network comprising of single neuron. As you know, activation functions operate on the weighted input, also called as weighted sum. In our case, the weighted sum is less than 0. ReLU simply sets any negative input to 0. But what does happen when a value is set to 0? As you might know, the gradient of 0 is also 0 during backpropagation. This means the neuron becomes inactive. It stops contributing to the learning process because its weights no longer get updated. This issue is known as the dying ReLU problem, where some neurons can permanently stop learning. For Leaky ReLU, we'll use the same values for input, weight, and bias and the same neural network. The weighted sum remains the same as in the ReLU example. To prevent a neuron from becoming inactive, Leaky ReLU doesn't set negative values to 0. Instead, it multiplies negative inputs by a small constant, typically 0.01, known as alpha symbol. What's the impact of using this small negative slope? It allows the activation function to output a small negative value instead of 0, which ensures that the neuron continues to receive gradients and keeps learning, even for negative inputs. Now let's illustrate Parametric ReLU and discuss differences between ReLU, Leaky ReLU, and PReLU. Here also, we assume the same values for input, weight, and bias and the same neural network. Weighted sum or weighted input will also be the same, that is -1. In PReLU, we take the concept of Leaky ReLU one step further. Unlike Leaky ReLU, which uses a fixed small constant, such as 0.01, called alpha, to scale negative inputs, PReLU treats this alpha as a trainable parameter. This means that instead of using a fixed alpha value to treat with negative inputs, PReLU allows the model to learn the most suitable alpha during training. This learnable alpha adapts based on the data, just like weights and biases. As a result, the network can automatically discover the most suitable slope for negative values, potentially improving performance and flexibility. This animation illustrates the concept of finding optimal alpha value during backpropagation. Now that we have determined the trainable parameter alpha as 0.01, let's examine what happens to the neuron, whether it becomes inactive or continues learning. To illustrate this, consider a simple neural network with a single neuron. The weighted sum is -1, and since the alpha for PReLU, the trainable parameter, is 0.01, the output becomes -0.01. This small negative output, instead of 0, ensures that the neuron continues to receive gradient. As a result, it remains active and keeps learning from the data, even for negative input. Lastly, now let's take a quick look at a comparison between these widely used activation functions in deep learning. All three activation functions help address the vanishing gradient problem, which is crucial for training deep neural networks effectively. However, each comes with its own strengths and weaknesses. ReLU, while fast and simple, suffers from what's known as the dying ReLU problem, where neurons can stop learning completely. Leaky ReLU improves on this by allowing a small output for negative values, though it still uses a fixed constant, which can lead to inconsistent results. PReLU takes this idea further by making that small slope learnable, meaning the network can adjust it during training for better performance. As shown in the table, ReLU is the fastest in terms of speed, but PReLU tends to give the highest accuracy and fastest convergence, thanks to its adaptability. So, if you're building a model where performance matters, PReLU might be your best bet. That wraps up today's video. Please don't forget to subscribe our channel, like the video, share and comment it to stay updated with this series.